The given question is, two schools A and B want to award their selected students on their values of sincerity, truthfulness, and helpfulness. The school A wants to award rupees X each, rupees Y each, and rupees Z each for three respective values to 3, 2, and 1 students respectively, with a total award money of rupees 1600. School B wants to spend rupees 2300 to award its 4, 1, and 3 students on the respective values by giving the same award money to the three values as before. If the total amount of award for one prize on each value is rupees 900, using matrices, find the award money for each value. Apart from these three values, suggest one more value which should be considered for award. Let's see the solution. Here we have taken matrix D, which represents the number of students receiving prize for the given three categories, that is sincerity, truthfulness, and helpfulness, from school number A, B, and as given in the question, one student for each value. So we get 3, 2, 1, 4, 1, 3, and one student for each value, so 1, 1, and 1. This will be our matrix D, and matrix X is XYZ, where the XYZ are the rupees mentioned and as in the question for the given three categories. E is a matrix representing the total award money for school A, B, and for one prize for each value, that is six. So the E matrix 1600, 2300, and 900. We can represent the given matrix in matrix multiplication as dx is equal to E, where D is our matrix, this one, and X is this matrix, and E is the prize money matrix. So solution will exist only if the determinant is not 0. This is a necessary condition. So to find out the determinant, we get 3 multiplied by 1 into 1 minus 1 into 3 minus 2 into 4 multiplied by 1 and minus 3 minus 1 and 1 multiplied by 4 into 1 minus 1. By solving this, we get determinant as minus 5. So determinant is not equal to 0. Therefore, the solution of this matrix exists. And the equation is X is equal to D inverse into E matrix. To find D inverse, we have to put in the formula D inverse is equal to 1 upon determinant into adjoint of D. So to calculate the cofactor matrix of D, the C11 position is calculated as minus 1, 1 plus 1, 1 into 3, and minus 3 into 1, so we get minus 2. By using this convention, we find out all the values of the cofactor matrix, and it comes out to be this. The adjoint of matrix D is basically converting rows into column. So basically this column is now this row, and the diagonal elements does not change. See, here is minus 2, 2, and minus 5. Here is also minus 2, 2, and minus 5. So the transpose of cofactor matrix is given by this matrix. D inverse is equal to minus 1 by 5 into this matrix. Now as D inverse has been calculated, we can put the value in this formula and we get this equation. We get this matrix we need to solve. By solving it, we get this matrix, and by further solving it by dividing it by 5, we get the values of X as 200, Y as 300, Z as 400, as here it is written. That's the answer. We can also say that award can also be given for punctuality.